In this video for day 7.3, we're going to be looking at surface area again, mainly for the figures that we call pyramids, cones, and spheres. So first we're going to identify what these are. You guys probably recognize what these look like. A cone is a solid formed where the base is a circle. Okay, so we got a circle on the base, and then every point on the circle is connected to this slanted side that comes up to meet at a point called the vertex of the cone. Okay, so we got a cone that looks like that. All right, the circle is a base. There's only one base to a cone. And then we have a pyramid. A pyramid is kind of like a cone. It has one base that could be any polygon. A lot of times we will use just a rectangle as a polygon, where the sides slope up on these triangles to a point. But the base could be a shape other than a polygon. We might have a triangular base, like that, or the base could be a hexagon or a trapezoid or a parallelogram. Any shape that has at least three sides could be the base. And then a sphere, you guys know what a sphere is, a ball or globe shape. Okay, and that's a sphere. All right, and there are certain formulas for surface area for these figures, but starting off, we're going to start with pyramids. Pyramids, the surface area is just the total area of all surfaces, okay? Okay, and then we will have capital B usually represents the base area, and then however many triangles make up every side of that. So we'll have n number of triangles, okay? And so we'll use our area formula for a triangle. Remember, the area of a triangle is 1/2 base times height. Okay, and then we do have two specific formulas for the surface area of cones and spheres. For the surface area of a cone, SA for surface area, that formula starts with pi r squared, which would be the area of your circular base, plus pi times radius times this cursive or script letter L. Okay? The script letter L represents something called slant height. Okay, which is not the height of your cone, that would be h, but the slanted height along the edge of the cone, like that. Okay, and what you'll notice is, we're going to talk about this more in class, but the height and slant height are two sides of what we could consider a right triangle. Okay, where this height down through the middle to the center of your circle is h, and that's one of the legs of a right triangle. The radius is the other leg, and the slant height is the hypotenuse. So we will end up using Pythagorean theorem from time to time for this. But this is your surface area of cones formula. Since the curved surface doesn't really have a polygon shape that it lines up to, we're going to use this. All right. For surface area of pyramids, again, just find the total area of all flat surfaces. But for a sphere, the surface area of a sphere is given as this. 4 times pi r squared. Okay, and there's a way that we can talk about this later, but this is the formula you'll need to memorize for spheres. So we're going to work on classifying and finding surface area for some of these examples. We'll do some examples in this video, and then others we will do in class. First, we want to classify this solid. This is a pyramid, but we don't want to just call it a pyramid. We want to name it by its base. So we would call this a rectangular pyramid because the base is this 9x4 rectangle. Okay, now as we begin to work on finding the surface area of this, you notice I didn't give you a whole lot of room here. So what I'm going to do, I'm going to use a separate sheet of paper, and you're welcome to do this if you would like. But I'm going to show my work on this. We're going to call this example 1. Okay, and I'm going to find the surface area for this pyramid. Now, what you'll notice is the base is a rectangle. Okay, if you want to draw that out, you can. Okay, this would be a 9 kilometer by 4 kilometer rectangle. So our surface area is going to include this 9 times 4 area, but then it will also include some triangles. Now, because of this rectangle having opposite sides that are the same, this triangle on front has a matching triangle on back. So there are actually 2 of these triangles that have a base of 9 and a height of 7.3. And you can tell they've drawn in them as these slanted heights along the actual surface of the triangle. That's important. And so we have 2 of those. And remember, area of a triangle is base times height divided by 2. So 9 times 7.3 divided by 2. And then we have 2 triangles on either side that have a base of 4 and a height of 8.3. Okay, and so I'll add 2 of those areas, base 4 times 8.3 for the height divided by 2. And then I just start totaling these up. 9 times 4 is 36. When I do 9 times 7.3, divide by 2 and times 2, what you'll notice is, since the triangle formula is divided by 2, that 2 cancels out with this times 2, just like it does over here. And so these 2 triangles total for a 33.2 area, and these 2 triangles on the sides here total for, I'm sorry, these 2 narrow ones are 33.2, and these 2 are 65.7. I got my answers wrong for my calculator, but that's how that should work. So when I add all of these up, we get a total surface area of 134.9 square kilometers. Okay. Okay, so let's find the surface area of our cone here. Okay, we're going to use that surface area formula for cones. All right, if you need to, write it in up here. Surface area is pi r squared plus pi r times slant height, L. This is your slant height, L. This is your radius. Now, I forgot to classify. This is a cone. Okay, it doesn't have a special name. It's just a cone. So our surface area is found by just plugging in radius and slant height. Pi times 9 squared plus pi times 9 times 20.1. And so we can plug that into our calculator, and in fact, we can put it all in at the same time. Pi times 9 squared plus pi times 9 times 20.1. And we get a grand total of 822.8 square feet. Sorry, I forgot my square kilometers. Okay, and finally we're going to find the surface area for a sphere. Remember, the surface area of a sphere formula is 4 pi r squared. And so what they're telling me in this shape is actually the diameter of this sphere is 16. So if the diameter is 16, the radius is half of that, 8. So we find our surface area by plugging into this formula, 4 pi times 8 squared. And again, we can plug that all in the calculator at once. 4 times pi times 8 squared. And we get a surface area of 804.2 square centimeters. Okay, we're going to save these examples to do in class. If you want to practice them and try them on your own, you're welcome to. But we're going to go ahead and move on to our next set of examples. All right, for these examples, we're going to find the total surface area of these composite figures. So we might be using some information from last time as well. So we're going to do just some of this. We're not going to do the entire thing. We're going to do this example because this uses 2 cones. Now, what I want you to pay attention to is the given information and what surfaces are actually being used. So we've got a cylinder, but we're actually not including the bases of either end of the cylinder. And then we've got 2 cones, but we're not including the bases from either of those. So if you'll remember from lesson 7.2, the surface area for a cylinder was 2 pi r squared plus 2 pi r h. And then from 7.3, this lesson, we learned the surface area of a cone is pi r squared plus pi r times L, slant height. Well, we only have these curved surfaces to consider for surface area. We're not going to include either of the 2 circles, which is where this comes from, of my cylinder, and we don't have the circle at either end of the cone. So we are only doing this for our surface area. Okay, so for part 1, which is a cone, we're going to use this formula, but only pi r times slant height. Well, the radius of both cones and cylinder is 2 meters. So for part 1, we have pi times 2 times this slant height of 3, plus our second part here, the cylinder, is 2 pi r times the height, which is the distance between the circles. 2 pi times a radius of 2 again, times the height of the cylinder is 3. Plus our third part, this other cone, which we're going to go back to using this formula, pi times the radius of 2 times this slant height of 4. And so we can simplify this. This is 6 times pi. 2 times 3 times 2 is 12 times pi. And 2 times 4 is another 8 times pi. Since these are all like terms, I'm going to group them and add 6, 12, and 8, giving me a total of 26 times pi. And then I'll plug that in the calculator. And 26 times pi is a surface area of approximately 81.7 square meters. Remember with surface area that you only include the surfaces that are on the outside. Things that are between the figures stuck together do not get included in surface area. That's why we don't include the circles on these ends. So we're going to try some more of these examples in class, but this gives you an introduction to surface area of cones, pyramids, and spheres.